Hey, happy Friday, everyone. Today is January 18th, and this is episode 44 of Get Your Tech On, our show on all things DOCSIS. I'm Brady Volp, founder of the Volp firm and Nimble of This. With us today is John Downey, the Ant-Man of Cable. John is also CMTS, technical leader of Cisco Systems. John, welcome back, and so good to have you with us.
The Ant-Man, does that mean I'm always bugging you?
Yeah.
Nipping at your heels? I'm like a fire ant.
Yeah, absolutely, man.
So I'm going to coin a phrase right now. 2019 is a year of foresight, because we all know 2020 is hindsight, and 2019 is foresight.
Well, we got the foresight now to predict anything that's going to happen in 2019, because everything hasn't happened yet. Although I have a couple of things in the news which I think are kind of interesting. So I don't know if you're a gamer, but Netflix thinks that Fortnite is a bigger competitor than any other streaming service. So I have this in here that this is according to Market Watch. And so Netflix, this down here, I found this interesting. What made Netflix's stance change from massive competitors of both sides? That they decided video game was more dangerous to Netflix's future. And it's probably, a lot of this is based on the success that basically Fortnite has come in as a completely free game, and they've just had an unbelievably successful time at doing this, and it's pulling people actually away. The other thing that's going on with Netflix, though, of course, you've probably heard, Netflix suffered a loss of 8% of consumers just by a $1 price increase in doing that. And so there was also some other things in this article that I came across in multi-channel news where, you know, they talk to people and they're just like, yeah, if they increase their price by $1, we're either going to drop it or we're going to drop to our lower price plan. So I was kind of just intrigued by that, by how sensitive people are to that. You know, so streaming is really important, but there's also a lot of new options out there with streaming or gaming. So I think these things are kind of interesting, how that can just completely change people's habits.
Yeah, meaning that there's a lot of people probably on the fence, and all they need is that straw that broke the camel's back. So they're either upset, and sometimes it comes back to customer quality of customer service, right? And it might have been they were ticked off about something. So you said it was $1 increase per what? Per month?
They had a number of increases. Yeah, it's per month, but they had a number of increases. Some of them were based on, like, you know, how many simultaneous channels you can do and stuff like that. Some of the increases were a little more, but this was the single biggest increase that Netflix has had in its history. And they also took a big hit on Wall Street too for that. So, but yeah, again, you know, just kind of interesting to see the whole over the top thing that's happening right now, and also on the video side. So there's, I don't know if you've been following the whole Fortnite thing. I happen to be a Fortnite player myself, but it's quite interesting. Fortnite's a really fun game. It's quite addictive. The thing that I find unique about Fortnite, and this goes back to quite a few years ago when EA, Electronic Entertainment, they had done a presentation at Cable Tech Expo many years ago, and they were saying, look, you really have to build a pipe for our games because we're going to have massive downloads on our game. Well, every few days on Fortnite, I will get and I'm kind of saying how much I play Fortnite. Every few nights when I go to open up my Fortnite, I play about, you know, maybe half an hour a night, but I'll get an upload or an update patch on Fortnite, and typically it's between 1 and 2 gigabytes that download is going to be. So yeah, it's really quite amazing how big the update is that you get from Fortnite, that you're going to pull 1 to 2 gigs for a single update. That's not the game. You've already downloaded the game. The update is what is impressive that you get just before you can start playing the game the next night.
And because it's a download and it's a file, so it's TCP based, right? So there is upstream traffic associated with it.
Yeah, there's absolutely AX on that. It's downloads and the upload portion for the acknowledgements for all the files that you're downloading.
Yeah, that's interesting. Yeah, I'm still waiting for the killer app for upstream traffic, and I always said I thought it would be home security, some type of Slingbox type of application. But home security, I think, is probably one of the bigger ones that people would create more upstream traffic. But downstream, like you said, we just keep coming up with new ways to increase downstream need. You know, I didn't think about the gaming aspect of the updates needing. It's like, what are they updating? It's not patches. They're downloading an entire file or gaming, or I don't understand. You know, that seems like a lot, doesn't it?
Yeah, I'm always surprised at how much they download, because I expect that you're going to see massive changes in the game, but it's really not massive changes. I mean, there are changes that are noticeable, but when you talk about gigabytes of data downloads, I really am interested in what the developers are doing. If they're just kind of, you know, pushing a new game down, or I don't know, but it is interesting.
Or a Trojan horse. There it is, full circle. Where Fortnite was created in China.
Yeah, well, yeah. I mean, you think they have millions and millions of people that are playing that, and every time they do that, you know, those people that do that download, it hits everyone's DOCSIS networks that are online doing that. So it's a big push. Can you control what time it downloads, or is it basically always during like off-peak hours, or, you know, midnight, or do you know? If you leave your computer running all the time, it'll just download whenever it comes. But you know, normally what happens, you turn your computer on and go to play the game. You say, oh, there's a download. So then you have to wait, and depending on what your speeds are, you know, downloading a gig and a half, 2 gigs of data can take quite some time. So you just let it download.
Yeah. And if you're like me, living in the sticks now, where I have a satellite with a metered service, I only get 30 gig a month allowance.
John, you couldn't play Fortnite over a satellite.
Good point.
Not going to happen. The latency, you know, so a unique thing about Fortnite is latency is really, really critical. And there have been times where I've had to go in and change the settings in Fortnite, reduce my resolution, because their latency on the network, especially in the evening, you'll die. Someone will shoot you before you even see them coming. Oh no!
Yeah. Funny, I don't think I muted my phone as well. So yeah, I mean, I think that's interesting. When we think we kind of have a handle on some of the traffic, and then something new comes along. And even on the Netflix side, I'd be curious to know the dollar increase. What was the baseline service fee? So was the dollar increase a 10% increase? Like, was it normally $10 and it increased by $1? That's 10% increase. And then they only lost 8% of the customers. So technically it's a 2%.
Is it a wash
in revenue? Yeah. Where is the inflection point, you know?
Yeah, it's tough to tell. It's very tough to tell. Hey, so, you know, it's been a while since we talked. What is new? Any new updates or changes since we talked last time on your side?
You know, Remote-PHY is obviously chugging along. There are some more systems that are looking at a little bit farther distances. So we look into this thing called dynamic latency measurement that has to be done to increase our map advance so modems come online properly. I had an interesting issue, and I'll bring it up. I won't say who the customer was, but there was an interesting issue where we had a customer with fiber optics that was still analog, still, you know, amplitude modulated AM fiber optics, and they did a fiber split. So not many people did redundant fibers back in the day, but this customer did redundant fibers. Whenever they failed over from one fiber to another, the modem doing upstream bonding, they would try to do their station maintenance, you know, every so often, depending on our T4 multiplier and all that. It could take 30 seconds, 60 seconds, whatever. But because it went to a new fiber, there's this gray area in the specs. It's funny. It's like DOCSIS has been around a long time, and I almost feel like I know DOCSIS pretty well, and something new comes up I didn't even realize. And this is part of the spec that's kind of a gray area for DOCSIS 3.0 is when a modem goes into partial mode and it does this station maintenance, it's basically locked on its old time offset, always.
Okay.
So if it goes to a different fiber and the fiber is a different length, the time offset's wrong, and it's going to fail station maintenance. So it fails station maintenance, it goes into partial mode. We have a default. Cisco has a default to say continue ranging. But that ranging in the spec is not specified to do initial maintenance type of ranging, like a broadcast or a unicast. Well, ours just keeps doing a unicast dedicated station maintenance, still using the old time offset.
Mm-hmm.
So in this situation where the fiber changes, the modem never comes out of partial service. And eventually all the upstreams go down and the modem goes offline. Now, once the modem goes offline, it will go back into normal registration process, do initial maintenance. It'll redo its time offset and come online fine. So the moral of the story is this is one more scenario that didn't really think about because not many people were doing it, where I could have redundant AM fiber links causing modems upstream partial mode, and there's really no workaround to get around it besides reboot the modem. So that was kind of interesting. And I told the customer, I said, this kind of goes away if you go digital fiber. Because if you go Remote-PHY, distributed access architecture with digital fiber, the time offsets that are reported from a cable modem and the CMTS negotiation is on the RF side. So RPD to modem. And that's only going to be coax of what? Less than a mile? Your distance is fiber, but the digital fiber, that doesn't affect our time offsets.
Right.
So I said the good news is digital fiber path changes will affect my map advance, which we have something called DLM to take care of that, but the time offset issue won't occur. Meaning modems will still have their same time offsets. You change the fiber, the time offset stays the same. Modem will still be doing station maintenance and all that and still be proper timing. So, I mean, I think that was kind of an interesting one.
So what's the impact to the subscriber when this happens? Is the modem offline, or is it causing collisions at the CMTS because the time offset is right? I mean, I could see both the scenarios happening in this case.
Yes, and yes. So in the one case, the end customer modem goes partial mode, end customer doesn't see anything because maybe a couple upstreams are still working. But if the timing is different, the CMTS is scheduling upstream mini slots based on the old time. So those upstream packets are all dropping, and they're not just dropping for that customer, they're interfering and affecting other customers' real data because everything has to be based on time, right?
Yeah. So this is kind of like, I mean, way back in the day when we had really kind of crappy modems with old crystals in them or old timing chips in them, we would see this exact same thing where the time offset they would be out of their mini slot window by like 400 nanoseconds, which was just in the DOCSIS specification, but it was causing modems basically to talk on other modems when they were talking, packet collisions when you have two RF packets that collide with each other. That creates an uncorrectable code word error. And it creates problems, and now we're just kind of repeating history, but it's a different technology that's causing it. So what's the fix for this?
I mean, that's a slow process, and they are in that mode, moving towards digital fiber. The other fix is basically reboot the modems.
Yeah, it's such a cure.
Write a script. You know, I had the one customer, and it was kind of interesting. He looked at the fiber distances, calculated, or even looked at the difference in time offset, and wrote a script to send a range request with a negative, what would you call it, calibrated time offset. Mm-hmm. So if he saw it was different by 500 ticks, he would kind of send a range request with 500 ticks subtracted, and he was able to get the modem to come out of partial mode and rearrange properly. So he didn't have to reboot the modem, which was kind of interesting.
So what if someone's running R-PHY in this environment?
So R-PHY, let's see. R-PHY is analog, right?
Yes.
But I mean, R-PHY, let's think about this. If you're doing fiber a decent long distance and it's redundant fiber links going to a 32-way optical splitter, right? Let's say you're going to an optical splitter farther out in the field, or it could be daisy chaining splitters, right? I've seen some designs like that. Because normally in an R-PHY solution, you're doing probably 32 max, maybe 64 max ohms, ONTs, maybe 32 to 64. And if you changed, then obviously all the time offsets are going to change. But in an R-PHY environment, everyone only their laser only comes on when they're transmitting. So if they're transmitting, but their timing is bad, they're transmitting at the wrong time, but so is everybody else. I don't know. If I change the fiber link and you got bad timing, I don't know. You still wouldn't interfere with everyone else's ONT because the ONT looks at energy coming in. Mm-hmm. Now your timing is bad, so no one's getting traffic properly, right?
Right.
But you probably wouldn't get any uncorrectable effect because you only transmit, or the laser only comes on when you transmit. Mm-hmm. That's the whole point of R-Fog, is not interfering with someone else and getting OBI, optical beat interference.
Yeah.
Right?
Yeah, the one...
Try to stump me on that one.
Stump the chumps. It's the name of our show.
Wrong.
Jeez. So where do you think ultimately this is going to lead? Is it, I mean, is this a major issue for R-PHY, or just a minor issue that once the modems are rebooted and stuff, it just all clears itself up?
Well, like I said, it's not even a problem with R-PHY. It was a problem with analog links.
Right.
When you go Remote-PHY, indicates you're going to digital fiber. So there isn't a problem with digital fiber. But, I mean, going back to Remote-PHY, I think that's where everyone's pretty much going. And I pushed moving the chipset into the node 10 years ago. And I told you before, I always thought putting the upstream chipset would have been the way to go. But it was hard for us to separate upstream and downstream. Mm-hmm. And then we did, right? We separated downstream, but we did modular CMTS, and we separated the downstream, but it was still within like 100 meters of the CMTS. So it was still basically the same location. Once we got Remote-PHY and we put the downstream and upstream together but far away from the core, then we were able to, work with DEPI, UEPI, other protocols, and get the timing properly and go to a pure digital fiber. But I mean, the digital fiber, dictates that you have no analog signal anymore, that's the next point. Is you asked about where I'm going with Remote-PHY. We are finalizing still NDF, NDR, narrowband digital forward, narrowband digital reverse. So we can support the old services that we had before for like path track and return path monitoring and CW carriage for pilot tones, for AGC pilot tones.
Yeah, it's basically things for like sweep and ingress, egress, leakage detection, stuff like that.
Yes,
so.
Yes. Yep.
So what do you think the timeline is for that?
I mean, we're awfully close. I mean, I would say, 3 months or so. We got trials going on now. What are you seeing with Germany and where they used to carry FM radio?
So
is there work to get rid of that?
No, they still have to carry that, but there's been, I think the biggest vendor is
Kronbeck.
Yeah, Bo Kronbeck, with his stuff there, he's come up with some nice like 1 RU boxes that can use the out of band basically capabilities between the CCAP and the RPD, the R-PHY node, that allows European operators to carry FM. So like if folks in the US don't know, so typically in the US we don't transport FM radio over the coax network, but a lot of European companies, that is how they transport their FM signals, like FM radio and stuff. They transport that over the coax network. And so when you go to R-PHY and you don't have that analog capability, just like we're saying for sweep and ingress and leakage stuff like that, there's a problem. So Kronbeck, Kronbeck Tracers is a company. He has nice solutions for European operators to do that. And that's a solution that can do that. But he's doing that over NDR, NDF, and some of the other out of band technologies, things like SCTE 55-1, SCTE 55-2, and stuff that allows him to do that. So, but we are also in the middle of doing the same thing, using the out of band capabilities for return path or RPDs and stuff in order to get the return path spectrum from the RPDs in order to do that type of analysis for our PNM solutions, proactive network maintenance solutions, because all the MIBs that Cable Labs has designed as part of the DOCSIS 3.1 specification do give the capability to get that same data from the RPDs, the Remote-PHY devices, except vendors like you are really focused on just, first of all, getting the communications going before you actually get to the point where you can get the MIBs working that Cable Labs is saying you have to eventually get working at some point. So when are you going to get those MIBs working?
Everything has priority. Everything has priority. I understand completely.
Yeah, so we're going to work with the out-of-band stuff first, whether it's, you know, SCTE 55-X MIBs or the NDR, NDF, whatever's supported, and make sure that we support those capabilities.
So on the PNM front, are you seeing more DOCSIS 3.1 type of PNM applications or functionality that wasn't there before? Is there anything new in PNM that was included in 3.1?
On the modem side, we're seeing amazing support. The support on the cable modem side is really starting to take off. So things like receive MER per subcarrier and some of the really cool stuff in the DOCSIS 3.1 PNM MIBs is now finally starting to materialize. So this is a big year for DOCSIS 3.1 PNM for us. We still haven't seen a lot on the CCAP side, on the CMTS side. Those are still, you know, we're waiting for those to come, kind of as we just said. But the cable modems are giving us a lot of rich data that we did not have available before. So we're spending a lot of time working on that, and this is just a gangbuster year. So it started happening last year. This is really the year that PNM is taking off. So much so that in partnership with the SCTE and Broadband Library, the next issue of Broadband Library is dedicated. Almost every article is dedicated to PNM. So it's going to be a really nice issue of Broadband Library for anyone who's not familiar with PNM to really come up to speed and understand what it has to offer, what it does, what its capabilities are. So I'm excited about the next issue. And of course, I have an article in there that, you know, shameless plug on my part.
Very nice. Very nice. Yeah, I've been curious about, you know, the PNM. You know, originally we always thought PNM was synonymous with pre-equalization on the upstream, but it's not, you know.
And you know, that was the way PNM got started, just looking at the pre-equalizers, but now it's diversified to where we're using CMTSs and RPDs to get return path spectrum analyzer data. We're using an A to D in the cable modems to get forward path spectrum analyzer data inside the subscribers' homes. So we're looking at the upstream, we're looking at the downstream, we're looking at return path spectrum analyzer data. And DOCSIS 3.1 adds a lot more power to that, to where we can really get into nitty-gritty things. We can see ingress under carrier, both in the downstream and the upstream. So you can look under QAM channels, you can look under OFDM channels, you can just see so much rich data out there that gives you the ability to, again, it's really focused on the PHY layers. So I know there's a lot of IT guys out there saying, well, you're not fixing the IT problems yet. We're going to get there, hopefully, because we are looking at Wi-Fi. We're looking at a lot of other aspects from a proactive standpoint. So it just keeps on expanding as operators understand the value and success that PNM offers, the funding and the value and the technology keeps expanding. So very exciting times. So yeah, so I think that's things we've covered on R-PHY, PNM optimization, DOCSIS 3.1. We did have a question from one of our listeners that came in that I thought was kind of interesting, that ties all this stuff together. He's a new employee from a company whose name I won't mention, but his colleague referred him to us. He's started watching us. He is I like this part. He says, I noticed you had some meetings with a Cisco expert. I can't imagine who that would be. I've gone back and watched every episode. I no idea.
Ron. Must be Ron.
Must be Ron, yeah. and also an Aris expert. I'm sure he's talking about Tall there. He said, it's amazing how you put the competitors together and build the ecosystem in the cable industry. He said he's from the wireless communication background. He says, I noticed many physical layer technologies and current cable technologies are from wireless communications, like OFDM, OFDMA, and LDPC codes. So, I think that is an interesting thing too, that he's commenting on. It's just how the technologies from the two industries are merging together. But he says he used to work on algorithm, he was an algorithm engineer to develop channel estimation algorithm. He says, I have a question. He said, so far, how well do we know that the cable channel, is it possible we can use frequencies above 1 gigahertz in cable? Can we do channel estimations in cable in order to achieve higher data transmission rates? And I hope we can fully exploit the cable channel as we did in the wireless channel. So, I hope we can do in cable like what we've done in wireless. So there's a couple questions in there, and it's just like, can we go above 1 gigahertz in cable? I think that's a pretty easy one. Yeah, absolutely we can. And the DOCSIS 3.1 specification, it's like we must go up to 1.2 gigahertz with an optional go to 1.8 gigahertz. So we are seeing, I've seen some plants that are going to 1.2 already. I'm curious, have you seen anyone going as high as 1.8 or doing any testing at 1.8?
No. So I tell you what, after Expo in Atlanta last year in October, there was a little bit of push. There's two things. For FDX, how do you shove this down someone's throat to do node plus 0 when they're in a rural area where you're only going to hit 5 houses with one node, right? It's economically infeasible. So It's not going to work.
It's inconceivable.
So that's why John Chapman talked about, node plus ? And coming up with an FDX amplifier. See, a node is interesting because on the node, you have fiber coming in, and on the RF side, you have a diplex filter. So you need echo cancellation, but only one. On an amplifier, you have 2 diplex filters, so you have to separate downstream and upstream on the front end and the back end. So you need 2 echo cancellation circuitry. So the idea now would be, could we offer a node plus 1, maybe 2, maybe 1? And when you look at a design for node plus 1, that could still be a lot of amplifiers branching off all over the place. It's still node plus 1, but it's branching off, right? Like a big octopus. But that node plus 1 could be the difference between, 100 homes per node versus 5 homes per node, So economically, it makes more sense if I can do at least 1 amplifier. But I have to put the echo cancellation there. So that was John Chapman's way of saying there is a solution for this, and let's get the industry to buy in on it, and we can put resources and development towards it, and then we can offer FDX. And remember, FDX is for faster upstream speeds. Bottom line, that's what we're doing FDX for. Then we heard some people talking about, well, could we do 1.8 gigahertz on the downstream to make the upstream move into the downstream spectrum higher, like a really, really high diplex filter. So it's not that I don't really need more downstream spectrum. I have faster DOCSIS 3.1. I could do MPEG or analog reclamation in the downstream, do IP video, get rid of all the standard definition and the SDT, the regular MPEG video, and do IP, and do all OFDM on the downstream. But if I need more upstream, I either do FDX and have a region that's upstream and downstream shared, or I get rid of the complexity of FDX and just increase my upstream into my downstream spectrum and then shift my downstream spectrum further up. So that becomes a lot to chew on, a lot to swallow, because right now, passives, 1.2 gigahertz, they're being installed now, no big deal. But you'd have to get new passives, new actives, new CPE. Who knows if the drop cable is going to be good out to 1.8 gigahertz. I almost think like the HFC plant's being upgraded now, and it's not too bad. But if you had to rip out everyone's drop line, you might as well do fiber to the home. If you get to that point, you might as well do fiber to the home. Fiber to the curb is great, but as soon as you have to rip out drop line and get to the house, then the economics there are going to be just astronomical. I mean, just crazy.
So, yeah, so this is actually a great topic, I think, and one that I have a lot of times with operators, especially when they are faced with fiber competition from, maybe a competitor or something like that, because we have a lot of downstream capacity, obviously, in DOCSIS 3.0 and DOCSIS 3.1. DOCSIS 3.1 minus FDX, not including FDX. And I think one of the most common questions that comes up for operators is, I've got lots of downstream capacity, but I need to determine how I can get more upstream capacity. The first thing is, of course, they max out their upstreams in DOCSIS 3.0, and then they have to figure out, okay, do I go to DOCSIS 3.1? Do I go to Remote-PHY? FDX isn't here yet, or do I go to fiber? So, we start playing these scenarios, and I start looking at, so OFDMA in the upstream is still kind of a little iffy, at least from my perspective. FDX isn't here, so then you start looking at fiber. But I guess the question I have for you is, where are we at with OFDMA in the upstream, and how much total capacity could an operator get with OFDM in the upstream today with a 42 megahertz return?
Acronym stands for, the time sharing, because there will be some inefficiencies, a lot of inefficiencies trying to share spectrum. What I would like people to do is, one, you have no 1X modems at all. Hopefully they're gone. 2.0 modems are going through attrition. The 3.0 modems, fine. But if you're in a 5 to 42 system, I would like to see the 4 ATDMA channels drop to 2 and keep a 2-channel upstream bonding group, which in one regard gives me 3 dB more max transmit power from 3.0 modems, because it's only 2 channels instead of 4. And then the rest of the spectrum from, say, 20 or so to 42, you make that an OFDMA block. So the 3.1 modems can peak faster peak speed. They can cross bond the 2 ATDMA with the OFDMA. The 3.0 modems would be relegated to the 2-channel bonding. The 2.0 modems would low balance between the 2 channels, and you would have more efficiency there. Then you might say, well, I'm just dropping speed from a 3.0 modems. No, you're hopefully upgrading the customers with 3.0 modems to 3.1 modems anyway, and they would be pushed to the 3.1 spectrum. So kind of like we do on the downstream, you'd have dedicated 3.1 spectrum on downstream. Well, on the upstream, I recommend the same thing. You don't try to time share the spectrum. You have spectrum for 3.1 modems. If you hit that inflection point where the 3.1 modems start to make sense, right? You can't do it if you only have 5 customers out there with a 3.1 modem.
Sure.
For 1 gig downstream, that's an easy upsell. You throw them on the 3.1 spectrum. Now they're actually alleviating some overhead from the single carrier qualms, because they're using the 3.1 upstream spectrum instead of the 3.0 spectrum, if you want to call it 3.0 spectrum. You know what I'm saying, right? The ATDMA channels. You're actually alleviating some of that spectrum. And then because the 3.1 modem is better, it might be able to do 1K QAM and get faster speeds and be done with its traffic faster than if a 3.0 modem was using that.
Sure. I still struggle with it. At the end of the day, the total amount of speed on DOCSIS 3.1, even if you have a really clean plant, which most plants in the upstream on a 42 return are not that clean, you're gonna be band limited on the amount of speed that you have.
But let me give you the number. So if you cross bond and you can get 1K QAM on the upstream, just with that 20 to 42 megahertz OFDMA and cross bond with the 2 single carrier QAMs, that's about, I think I did the math, it's about 200 megabit per second aggregate. So you could offer 100 meg service. And I think that's the goal, to offer a 100 meg upstream service in a 42 megahertz plant. If you need to offer more than 100 meg, you better increase it to 65, 85. I see a lot of systems upgrading to 85 megahertz. So back to that 1.8 gigahertz downstream idea versus FDX. I almost wonder, I'm going to bring this around full circle because I have my own ideas. I almost wonder if you look at the spec, 42 megahertz was the spec, 65 in Europe, 85 for DOCSIS 3.0, 212, what is it, 204, right? 204 megahertz for DOCSIS 3.1.
Mm-hmm.
I almost think we should have made one more above that. Not FDX, but just another split, maybe closer to 400 or so. Now, when you make a diplex filter, I think the higher up you go, maybe the filter has to be a little bit wider because of octaves or whatever you call it. Like when you get a smaller upstream, I think the filter can be narrower. And as you increase the upstream, the filter separation between upstream and downstream has to be a little bit wider. Like an 85 megahertz filter is an 85-105. So there's 20 megahertz of space, no man's land. So if I go to 204, it's a 204-254. That's 50 megahertz of no man's land in a diplex filter.
Yeah.
My point is, if I go up to 400 megahertz, does it have to be a 400/500 megahertz filter, and I lost 100 megahertz in the diplex filter region? My point I'm getting at is I need to open up. The bottom line is speed. How much speed do I need before I go to fiber? And if we can hit 5 gigabit per second on the upstream, what would it take to get there? And I believe if we went to, and I don't think we would hit 5 gig, but I believe we went to 400 megahertz and we do some OFDMA blocks, 4 blocks or so, and we did 1K QAM, we could get very close to 4 gig aggregate. It would be close. We might be able to offer a 2 to 3 gig offering on the upstream. And that might be the difference between an upgrade for 5 years or, not having to do fiber upgrade until the prices of fiber come down even more, and then that's an easy sell. I don't know.
Yeah, I think it's going to depend on the geography or the regions that operators are in, because for some operators, it's going to be a lot easier just to go to fiber. And I think that's that's just a simple reality of it. So yeah, I see Brian Wilson in the chat room saying, E/GPON, and I just think that's the simple solution sometimes. Sometimes simple's easier.
Yeah, yeah. I mean, it definitely is. I mean, it all comes down to money, right?
Yep,
like,
absolutely.
At the bottom, when you just do all the math, counting in everything, then is it cheaper or not? Or is it more cost up front and then it's cheaper in the long run? I don't know.
Yep, absolutely. So, all right. Anything else on your mind in this early 2019 that we're not prognosticating? We're procrastinating. We're procrastinating
our prognostication.
Yes,
we're in the year of foresight, and not Fortnite. Not Fortnite, but foresight.
Yes.
Yes. Let's see. So we got FDX. We have Remote-PHY. We have DOCSIS 3.1.
Do you think we'll have any FDX deployments this year? Do you think that's actually possible?
Yeah, I think so. I mean, we just started the year. So we're even doing our own little outside plant install in our Lawrenceville lab. But obviously, that's a lab and it's outside. But you're talking about deployments.
That's a lab.
It's semantics. It's semantics. When you say deployment, is that paying customers or friendly customers that aren't paying?
If it's in the field in real life conditions, I would consider that a deployment, because I really want to see. I'd love to see FDX in a real world environment.
I believe we will this year. No problem with that. And we even said, will we see cloud? Well, we already have, mid-continent cable doing some cloud stuff.
Mm-hmm. And I've got clouds over my house right now, so I believe that.
I'm always looking for that silver lining, though. So cloud is another one. It's like, will it happen? Yeah, it is happening. Yeah. It's not going to happen everywhere, but people are just going to cherry pick where it makes sense for now. So virtual cloud. There's a lot of changes.
So, quite a question just come in. Should 3.0 system take a very hard look at fiber to the home rather than R-PHY and D3.1, especially in rural areas. And I think that's an important differentiator too. Rural areas pose a real challenge for operators. So if I have a DOCSIS, if I'm an operator in a rural area and I'm running DOCSIS 3.0 now, you know, and I start to balance DOCSIS 3.1 versus fiber to the home, that I think is a challenge. Because
the one thing that always holds us back is video. You know, if you run EPON, GPON, how you get the video? You might say, well, let's just do RFOG. We'll do fiber to the home, but it's RFOG, fiber to the home.
Yeah, I've talked
but then it's analog fiber again. I'd rather do digital. I'd rather do a distributed access architecture, Remote-PHY, as deep as I could, and maybe it's fiber to the neighborhood, and then I still be cheaper to run coax to those houses.
Mm-hmm.
You know, it would be. Instead of running ONT or EPON, GPON to each customer, it's like, what's your return on investment there? Once I get trenching done and right-of-ways and fiber, you know, putting a node on somebody's house, what is it going to take me 5 years to get my return on investment? Whereas maybe I do Remote-PHY close enough, as close as I can get, and I just do one line extender and just run coax, and then I look at my total cost, and it was a lot cheaper, you know, 10x or 1/10 the cost or whatever it happens to be. I don't have the numbers, but I'm just guessing, you know.
Yeah, it is interesting in talking to a number of rural operators. They're really trying to determine whether or not they're going to continue keeping video as we know it, or if they're going to partner with just an over-the-top solution provider. So video could just go all IP, and that takes away that hurdle for operators to deal with video.
Yeah, I agree, because that is one of the bigger hurdles is how do you get the video?
Yeah, absolutely. So, all right, anything else on your mind, John?
No. When's the next big conference?
Well, Angacom is the big one that'll be in the end of April, beginning of June. I'll be attending that one. You have any plans to go to that one?
I imagine we'll probably be there like we were last year.
Yeah.
I haven't heard anything yet, but did it move it up to May or is it still in June?
It's normally end of May or beginning of June. I don't have the dates on the top of my head here, but I know I've been having discussions with them to go to that. I'm also going to be going and speaking at the SCTE UK in the end of March as well. So I got a little presentation there.
I think there's a Cable Labs or some type of light reading conference in Colorado coming up in March. Not really sure if that's open to everybody or what it is.
Yeah, I think I got something on that. I just haven't signed up for it yet. And I think Cable Labs is also having a webinar like the end. I think I signed up for it's next week or something. So I think that is
actually. I think Ron's on that one.
Yeah,
I think Ron's on that next Wednesday.
Yeah. So if anyone hasn't signed up for that, check in on Cable Labs on their website. I think that's an open to everyone one. So worth going.
Ron's doing Remote-PHY. I think it is.
Yeah, so the UK, SCTE UK is March 26th and 27th that they're having a meeting. So if anyone over on that side, please attend. I'd love to see you there in person.
Bring your Brexit sign.
Yeah. You didn't have to bring that up, John. I'm sure they don't appreciate that.
Why not? We can't be the only ones people make fun of.
No, they can make fun of us, but
yeah.
Everyone does.
You know what occurred to me is every time I grab a drink of my drink, this is a pre-workout, and I'm looking at it. I'm like, I wonder if someone thinks that's like the C4. Wasn't that Casa?
Yeah, C4. That was
Gain Speed.
It was not. It was not. C4 went to Eris, but it was originally in California. Who was it? I can't remember the name of the company.
Was it Gain Speed?
It was not Gain Speed. It was before. It was Com21. Was it Com21?
No. I don't. No, it couldn't have been Com21. But I remember the C4 was a CMTS brand, right?
Yeah. Yeah, it's Eris.
And then I think
Eris had the C4. I know they were supporting the C4 still because I know we see them out there. But yeah, that is that CMTS is still out there. That I'm pretty sure that was someone before Aris, but they definitely have it, and it's a good CMTS. So
yeah.
You all make good CMTSs, man.
And speaking of, the segue onto that, Aris and CommScope, right? CommScope,
yes.
Did they finalize that?
I don't know. I haven't seen anything recently. I've talked to some Aris folks, and they all seem pretty comfortable with it, at least what they told me. So
yeah,
I think they're on the technical side, so I think they're secure in their jobs.
Yeah, business as usual. Just keep chugging along.
Yes. Well, we'll have someone on one of our upcoming shows. I know from Aris we're going to have probably Tall or someone back, and we'll have Asaf on an upcoming show. Our next episode is episode 45, scheduled for February 15th. So I'm hoping to get one of those either Aris or Tall or Asaf, if they're available, scheduled for that date. We'll check their availability. So stay tuned for that. And we, as normal, we try to do our best to bring some relevant content for everyone on each episode. So if you like what you're what you're seeing on here, please do hit the like button, hit the subscribe button, get our latest episodes, or catch us on voltfirm.com/events, or download the audio only version if you don't want to see John's face or my face on here. I can appreciate that. So, John, thanks for your time today. We are at the top of the hour almost, and everyone else, thanks so much for watching. We will catch you on February 15th on our next episode. So long, all. John, we'll catch you later. Thanks so much.
All right. Thank you. Pleasure as always.
Yeah. So we'll transition out here.